Okay, dear children, now we will solve the word problems of exercise 5.3. Okay, it's very simple. Question number 5. By which number should 32,768 be multiplied to get a perfect square? So what you will do is that you can either follow prime factorization method or long division method. Okay, whatever the method you are comfortable with, you can follow. Okay, now I have followed this prime factorization method out here, okay, and you can see that there are 15 twos appearing out here, okay. So there are total 15 twos out here in total, okay. 1, 2, 3, 4, 5. There are 15 twos, okay. So 32768 equals to 2 into 2 into 2 into 2. So there are 15 twos out here, okay. Now you have to find a perfect square. Okay, and for a perfect square you must make a pair of twos. Okay, and for a perfect cube you must have the pairs of 3. Okay, for a cube root there must be a pair of 3, and for a perfect square there must be the pair of twos. Okay, so what you will do is that you will make the pairs. Okay, so this is one pair, one pair. Okay, so you keep on making the pairs. Now you can see this number, this 2 is left out. It has no pair, isn't it? But if it is multiplied with another 2, then it can be a pair, isn't it? If it is multiplied with 2, then it can be a pair. Okay, then it can form a pair out here. Okay, so hence 2 should be multiplied with this number to get a perfect square. Okay, so this is how you will find the missing number. Okay, so that's the question number 5. Very simple. Let's go to question number 6. So I have followed this prime factorization method out here because I like this method very much. Okay, so this is my personal take, and as I have already explained that this method, okay, this prime factorization method, it gives you answer in a better way. Okay, but however you can follow the long division method also. Okay, if you are comfortable with long division method, please follow that. Okay, there is no such hard and fast rule that you have to follow this prime factorization method only. Okay, now after finding the prime factorization of 1715, we can see that this is the number. Okay, so for the perfect cubes we must have a pair of 3, we know that. Okay, but this 5, it has no pair. Okay, but if it is multiplied with 2 5s, okay, 2 extra 5s, then it can form a pair. Okay, let me just do it in red color. Okay, so if we multiply with extra 2 5s, okay, then it also can form a pair. Okay, now 5 into 5 is how much? 25. So hence 1715 should be multiplied by 25 to get a perfect cube. Okay, if there is only let us suppose that if there are 2 5s and 3 7s, then your answer would be 5. Okay, because at that point of time we only need one 5. Okay, so at that point of time your answer would be 5. Okay, but this number would be completely different. Okay, but in this particular question the situation is like this, that there are 3 7s and only one 5, so we need extra 2 5s. So 2 5s means 5 into 5, that is 25. So 1715 should be multiplied by 25 to get a perfect cube. Okay, so that's your question number 6. Now let's move on to question number 7. Question number 7 is also simple. Just read the question first. Okay. A builder bought 1,450 tiles to put on the 4 walls of a cuboid bathroom. He found out that he was 150 tiles short. What is the number of tiles which can be arranged in one row on the wall? Now you will write number of tiles brought 1450. Okay. Now the shortage of tiles, that is 150, which means the total number of the tiles is 1600. Okay, 1450 plus 150, that is your 1600. Okay, so we know that there are 4 walls. Okay, we all know that in a room that there are 4 walls, isn't it? So the number of sides of a wall equals to uh, sorry mm, number of sides, sorry, number of walls, sorry, number of walls of a cuboid bathroom. Yeah. Okay, of a cuboid bathroom is 4. Okay, so there are 4 walls in a room. Okay, so bathroom is also a room, so where you take bath. So there are 4 walls. And what you do is that you just divide this number of tiles by the number of walls. 1600 divided by 4, you will get 400. Okay, and after finding this 400, what you will do is that you will simply find the square root of 400, and that's the number of tiles that can be arranged in one row on the wall. Very simple.